Hello everyone, today you will be learning special products, so make sure you listen to our discussion carefully and don't forget to take down notes.
Mathematics Online.
Now you will be learning special products. On the previous discussion that we discussed how are we going to simplify grouping symbols, and after that we discussed about binomial products. Now we are going to apply those two topics that we've learned to this topic that we're going to have now, which is called special products. Now, what is a special product? This is a special way of multiplying or expanding grouping symbols. Alright, it's an special way of multiplying and expanding grouping symbols. Now, what are the types of special product that we will be learning today? Right? The first one would be perfect square. Alright, perfect square. Now, how do we do perfect square? Write the binomial and multiply by itself. Alright, you have to multiply the binomial by itself. Now, here is the equation. So for example, you have x plus y is equals to 2. So therefore, we write the binomial which is x plus y, and then we multiply it by itself. So x plus y. Then we substitute and we simplify this using binomial products. Alright, binomial products. Multiply the terms of the first binomial to the terms of the second binomial. Alright, so we have x plus y times x, no, not plus, sorry, this one here now. Right, times x plus y. Then we simplify, we have x squared plus xy plus xy plus y squared. Alright, and then we combine like terms. If you remember our binomial product, we combine like terms since they are the same. So therefore our new product would be x squared plus, we add the 2 to 1 plus 1 equal 2xy. There are 2xy there plus y squared. So this is now your product when you have x plus y raised to the power of 2. Okay, so the answer would be x squared plus 2x plus y squared. Now let's have a quick example. Alright, let's have a quick example. For example, I have here a plus 3 squared. So first thing first, we use binomial product. We write first the binomial and multiply it by itself. So we have a plus 3 times a plus 3, and then we use binomial product. We have a times a plus 3 times a plus 3. Then we distribute, we use simplifying grouping symbols. Alright, so we have here a squared plus 3a, and then plus 3a plus 9. Again, combine like terms, we have a squared plus 6a plus 9. So again, we combine these two because they are the same. Okay, next. What if we have here m minus 5 square? So again, we go to the basic rule. We write the binomial m minus 5 and we multiply it by itself, m minus 5. Then the next step they're going to do is we use binomial product. We multiply all the terms in the first binomial to the terms of the second binomial. So therefore we have here m times m minus 5 minus 5 times m minus 5. Okay, now when we are going to expand it, we use the simplifying grouping symbols. So we distribute it inside. So we have now m squared minus 5m, then minus 5m plus 25. Okay, then we combine like terms. Okay, since this one here are the same, so we combine them. So our answer would be m squared minus 10m plus 25. That's how we expand. All right, that's how we expand perfect square. All right, this is how we expand perfect square. Perfect square, write the binomial and multiply it by itself, and then we follow the rules. All right, we follow the rules that we have when we do binomial product and simplifying grouping symbol. All right, we go for the next type of special product. The next one is difference of two squares. All right, difference of two squares. Okay, the sum of the sum of two terms. Let's see, the sum of two terms multiplied by their differences. All right, their difference is equal to the square of the first term minus the square of the second term. Alright, difference of two square, the sum of two terms multiplied by the difference is equal to the square of the first term and the square of the second term. Alright, for example, we have here x plus y minus x minus y. Okay, then we simplify this by using binomial product. We have x times x minus y plus y times x minus y. Okay, so we distribute using simplifying grouping symbols. So we have x squared minus xy plus xy minus y squared. Now notice again, we combine like terms. So since they are on different sign, we subtract, so therefore it becomes x squared minus y squared. So this is what do you mean by their difference is equal to the square of the first term and the square of the second term. So square the first term and square the second term, and the sign would be minus because it is difference. Okay, let's have a quick example. Alright, let's have a quick example. So if I have here x plus 3 times x minus 3. Alright, then we simplify using binomial product. So we have x times x minus 3 plus 3 times x minus 3. Then we simplify x squared minus 3x, then plus 3x minus 9. Then the answer would be, we combine like terms because this one here they're the same, so therefore we have now x squared minus 9. Alright, because the middle term is 0. Now we proceed to our next example. We have, for example, we have 2a minus 3b times 2a plus 3b. Alright, and then we use binomial products. So we have 2a times 2a plus b plus 3b, correct? Then minus 3b times 2a plus 3b. Then we simplify using simplification of grouping symbols. So we have 4a squared, okay, plus 6ab minus 6ab minus 9b squared. Again, the middle term, they are the same, so we subtract because it's a different sign. So therefore, our answer here would be 4a squared minus 9b squared. Alright, so that's how we simplify difference of two squares. So again, the two types of special product that we're discussing today is perfect square. Alright, look at the pattern for perfect square. And the final answer to which will be this. Again, don't forget, guys, alright, in here we combine like terms. Alright, okay, now we have an example. So we have the answer for which will be always a trinomial. Okay, the answer for both will be always trinomial. Now we have difference of two squares. The sum, remember this, the sum of two terms multiplied the difference is equal to the square of the first term and minus the second term. Alright, so we have here, if you have here the first term, you multiply that, so you have the square. If you have the second term, your answer is this, and the sign in the middle would be difference. So we have now the answer here, so that would be the difference of two squares. So this is just a few, just the first two type of special product that we can use when we do simplify grouping symbols and we use binomial products. So there is a connection between the three topics that we have, from simplifying grouping symbols next to binomial product, and now we have special product. Okay, so that's it for the topic that we have here for special products. So if you have any questions, feel free to comment. I'll be very much willing to answer all your questions. So I hope our discussion today is clear. All right, thank you.